Okay, this video is about dividing complex numbers, often called rationalize the denominator. Okay, so let's do an example of this. So let's say I were taking a real number 4 and I wanted to divide by the imaginary number 2 plus 6i. So we have this rule which states that you are not allowed to have an imaginary number in the denominator. Not allowed. So we have to get rid of this. The way we do that is something called rationalizing the denominator. We're going to get rid of this imaginary number. If you watched my video on complex conjugates, you'll know that the complex conjugate of the denominator just means you switch the sign of the imaginary number. So 2 minus 6i is the complex conjugate of 2 plus 6i. So what I'm going to do here is I'm going to multiply by a fraction that has the complex conjugate of the denominator in the numerator and the denominator. The reason I'm allowed to do this is really all I'm doing here is I'm multiplying by a very strange looking number 1, because this is really just multiplying by the number 1. So I'm not actually changing the value of my fraction at all. And the reason I do this is because when you multiply conjugates, the imaginary number goes away. So there won't be an imaginary number in the base in a moment. Let's see, what do I have to do? Well, looking at the numerator, I have a constant times a binomial. So I'm going to distribute. 4 times 2 is 8. 4 times negative 6 is minus 24i. And my denominator is, okay, a binomial times a binomial. Not so easy. We have to actually FOIL this. So, what color do I want to use? Let's take this one. So I have to do 2 times 2, that's 4. 2 times negative 6i will be negative 12i. I need to extend my fraction bar a little bit because this is going to be a little long. Then I have 6i times 2 is plus 12i, and 6i times negative 6i is minus 36i squared. All right, well, next what I can do is simplify the denominator. So my numerator is going to stay the same, but on the denominator, I can say negative 12 plus 12i, that's 0. So I have 4 take away 36i squared. The next thing I can do is I can plug in for that I squared, because we know that I squared is equal to negative 1. So I have 8 minus 24i over 4 minus 36 times negative 1, which is equal to 8 minus 24i over 4 plus 36, because a negative times a negative is a positive. Then what can I do? I can simplify the denominator. So that is equal to 8 minus 24i over 4 plus 36 is 40. And there's one more step I have to do here, which is to simplify this. What number goes into 8, 24, and 40? Well, that would be 4. So I'm going to divide by 4 over 4. Actually, a bigger number, 8. And 8. So really, my solution is 1 minus 3i over 5, which in the form a plus bi, that would be 1/5 minus 3/5 I. Ta-da! Let's do one more example really quick. So the other example I'll do here. The difference now is that I'm going to have a binomial on top and on bottom. So let's just do 4 minus I. So here I have a binomial on top and a binomial on bottom, or rather a binomial in my numerator, a binomial in my denominator. Same process, I multiply by the conjugate of the base. So the conjugate of this would be 4 plus I, 4 plus I. And then we do the same process. It's just a pain in the butt because you have to FOIL the numerator and the denominator. So 2 times 4 is 8, 2 times I is 2I, 3 times 4 is plus 12I, and 3I times I is plus 3I squared. And then you put this over. Okay, we're going to multiply the complex conjugates. So now I have 4 times 4, that's 16. 4 times I, that's plus 4I. Negative I times 4, that's negative 4I. Negative I times I is minus I squared. Okay, moving on. I can simplify my numerator. 2I plus 12I is 14, so I have 8 plus 14I plus 3I squared over. Now what can I do? I can cancel 4I minus 4I. So I have 16 minus I squared. Now what I can do is I can plug in negative ones for both of those. So my numerator will become 8 plus 14I, that's a 14, plus 3 times negative 1 over 16 minus negative 1. One last step, which is that I can combine this and this. So my numerator is 8 minus 3, which is 5 plus 14I. And this is the same as 16 plus 1, which is 17. So that's my final answer. And I can write it in the form A plus BI by going 5 over 17 plus 14I over 17. Yay!